day 2 with just some examples. No new content, no new essential question. We are still finding the surface area of cylinders and of right prisms. And we spent some time going over cylinders. Usually cylinders are the easiest ones because we can easily find the radius and height. They have to be given to us in some capacity. So we're going to focus on prisms today, in particular a pentagonal prism and a hexagonal prism, and how we're going to find the surface area of those. So our example 1, we are going to have I almost wrote hexagon, pentagonal prism. More specifically, a right pentagonal prism, because this will not work for non-right or oblique when they're kind of slanted. We're talking about shapes that are at a 90 degrees or right to their base. So we do need our formula. You don't have to have it memorized. You do have it on yesterday's notes as well. But the surface area for any right prism is the perimeter times the height plus 2 the area of the base. And so I'm going to draw a little pentagonal prism out here. You do not have to draw this. I'm going to do it the best I can. So I'm going to draw a little pentagon. It might not look like a regular pentagon with all the same sides, but that's okay. We're going to pretend that we're not looking at it straight on. We're going to kind of draw it sideways like this. All of the sides are going to come down perfectly vertical there. And then the bases need to match the top. So in this case, the bottom side of the base, it's perfectly horizontal, so this one will be horizontal. This one looks like it tilted down at like a 30-degree angle. This one is going to tilt down at a 30-degree angle. Same thing over here. You want to keep those same like degree measures. So that's my really poor version. You want to keep that straight down and a little bit over here. So we have our pentagonal prism. If I could guarantee that all of you had printers, this would be a lot easier, but we're just going to do our best here. So I'm going to give you some things, or some things are given to us. Let me use a different color. So here, our apothem is 12 meters. One leg right here, or not leg, what am I saying? One side of the pentagon is 17.46. And lastly, the height is 16 meters. Oh, and that's also meters. Okay, so a ton of stuff is given to us. We got to figure out what it's looking for and what's already given to us, because some of it's already given to us. We need the perimeter, we need the height, we need 2 of the bases. I'm going to regret that because I'm going to need bigger spaces, but whatever. So the height, that's already given to me. Awesome, that's 16. Done. Figured that out. What does big P stand for again? If you have your formula sheet, you don't have to memorize that. Over here, oh no, you do. That's okay. But most of the stuff is given to you over here. But that big P stands for the perimeter of the base. So the perimeter is the whole thing here, all of that added up. And if there are 5 sides and each side is 17.46, we have 17.46 times 5. That's my perimeter. My perimeter is 87.185. And I'm going to squeeze that right in there. And I've been rounding to the nearest 10,000th. You could round to really whatever you wanted to do. And lastly, our base. So in this case, our base is a pentagon. So my base in this case is 1/2 the apothem times the perimeter, or perimeter times apothem. I'm getting that again from our formula sheet. If I have a regular polygon or a regular pentagon, I'm going to use that area formula. So there's my area formula. A lot of it's given to me. Actually, all of it is. My apothem is 12. The perimeter is, we have it right here, 87.185. Plug that all into your calculator, and your area is 523 meters squared. And so we were able to find all these pieces. We were able to find the area of the base. We've done that for 2 weeks now, finding the area of a pentagon, for example. Finding the perimeter of the pentagon, either being given the height or somehow finding the height, and then plugging it all into your equation. type that all into a calculator. If you want to do it longhand, be my guest, I would not. Type that all in and you are going to get, I'll use a different color here, 2,440.96. And I rounded along the way. Some of these, I rounded the perimeter, and then therefore I had to round this answer, and therefore I rounded that. So if you got anything around there, you're pretty good to go. Let's try another example. I'll leave that there if you want to pause the video. We're on to our second example, and our final example actually. We are moving on to a hexagonal prism. So a hexagon has 6 sides. Everything stays the same. Actually, we're going to use all the same formulas, but I'm going to give you less, and you're going to have to do more work. So let's see what that's going to look like. Okay, this is a hexagonal prism. I know the base is a hexagon, so when I look for the area, I'm going to have to use this formula. 1/2 is equal to apothem times perimeter. I'm going to draw my hexagon. You do not have to if you just kind of want to watch here while we're doing this. Your hexagon, a hexagon is not going to look regular, even though it is. It's not going to look like all the sides are the same and all the angles are the same. Because, just like before, I'm drawing this as if we kind of were looking at it. This is a hexagon, or a pentagon, but I'm going to look at it a little bit on its side. I'm not looking at it like this, I'm kind of looking at it like that. Again, we want to make sure that all my sides or all my lateral area is vertical. And my bases match up in terms of like horizontal, kind of slanted to the right, kind of slanted to the left. So there's my hexagon. If you wanted to put the invisible markings behind, you could. I don't think that's necessary, but if you want to get really good at 3D shapes, which is something I had to work on as a teacher, that's how you're going to do it. Okay, so it's a prism. I take out my formula sheet. I know that it's perimeter times the height plus 2 of the bases. Now let's look and see what I know and what I don't know, what I need to find. Okay, this is what's given to you. Your hexagon has a height of 10 centimeters. It also, this measurement right here is 4 centimeters. And that is all that is given to you. So some of it's given to you, you know your height, easy. That height is between the, the distance between the 2 bases. I need the perimeter of the base, and then I'm going to use that perimeter to find the area of the base. So let's find the perimeter first. The perimeter of the base, I guess they're both exactly the same, but it's hexagonal. I know it's a regular hexagon. If it didn't, I'd need to know a little bit more, but it's 6 sides, 4 centimeters each, so it's 24 centimeters as the perimeter. And at this point, we now just need to find the area of the base. So I'm going to find that area. So the area of the base is 1/2 the apothem times the perimeter. And I know the perimeter, I just found it. So I just need to find the apothem. This is a hexagon. I'm going to draw out the hexagon. Man, I'm struggling with the drawing thing here today. Because I know that that's 4, and I need to find the apothem. Well, this should look familiar, because we need to set up some right triangles. We're going to either set up a 30, 60, 90, or special right, that was a special right triangle, or trig. I'm going to use trig. This is 30 degrees. I'm given my opposite, so that's 2 right there. I'm given my opposite, and I'm looking for my adjacent. So I'm going to use tangent is equal to opposite over adjacent. I'm going to plug in what I know. Tangent of the angle that's given is opposite over adjacent. And I'm going to put a little a there because a stands for adjacent or apothem. Super fun. I am looking for the apothem. Do your magic. Come up with the apothem is equal to 2 divided by tangent of 30. Plug that in your calculator or your computer, depending on what you're using. And you'll get 3.464, and I'm rounding a little bit there, centimeters as your apothem. So we're going to plug that in right there. 3.464 plug that all in your calculator. Your area is centimeters squared, and so if you are looking for that, technically your answer just for that area would be centimeters squared. That is 41.568. And at that point I have, oh, you can see that. And at that point I have everything I needed. So the height is usually given to you, or it'll be easy to find. The perimeter, again, probably the easier one to find. And then use the, or find the area using the perimeter. Plug that all in, see what you get. You should get, I'll give you a second if you're using a calculator, 323 should we just round 14 centimeters squared. I just noticed that up above here I put meters. Sorry, that should be meters, and down here should be centimeters.